Bismillahirrahmanirrahim. Greetings. I am MD Nafis Alvi Brian, MD Nafis Alvi Brian, ID 235238872 from Section J. Today I'll briefly explain my OBE assignment for the Digital Logic Circuits course, where I designed an automated parking control system using counters, triple five timers, and finite state machine concepts. I'll explain my solution part by part, focusing on the logic and design decisions. So moving on to part one, in the first part, I outlined the essential steps to develop. The block diagram and flow diagram of the parking system. Here in this case, the system starts by taking the maximum. Then moving on to the question. The system starts by taking the maximum parking capacity from the keypad, which is calculated using the digits of my student ID. Here you can see, and then entry and exit sensors detect cars entering and leaving the garage. These sensor signals are connected to an up-down counter where entry sensor increments the count and exit sensors decrements the count. Inside the counter, I showed how the D flip-flops are connected to the store and update the car count synchronously. The counter output is continuously compared with the maximum capacity. Based on this comparison, if counter states equal capacity, it should display full. Otherwise, display space available in the blinking mode. And now moving on to the flow diagram, here it states reflects the logic sequentially: initialization, sensing, counting, comparison, and display control. Now moving on to this is my counter diagram, and here I've displayed the sensor. For up, the value is equal to 1, and down it's 0, and maximum count is 13. Here is the K-map and counter flip-flop excitation state table, and the present and next state table. And here are the K-maps for the circuit diagram and the circuit diagram. Now moving on to part 2. In the second part, I designed the display control circuits using two separate 555 timers. The first 555 timer is used for the full display since full must be displayed continuously. This timer is configured to provide a steady output without blinking. When the counter reaches maximum capacity, logic gates activate this timer and enable the full display. Timer 2 displays space available blinking. The second 555 timer controls the blinking of the space available display. Here the duty cycle and the frequency are calculated using the provided equations based on my ID digits. I selected appropriate resistor and capacitor values from the given capacitor options to achieve the required TH on time and TL off time. The blinking effect helps drivers visually identify availability, improves real-world usability. Since 555 timers do not have enable inputs, I used additional combinational and sequential logic to control when each timer is active. This ensures no conflict between displays, smooth switching between full and space available states. Now, here are the calculations that I have done. Now moving on to the part 3. In the third part, I designed a finite state machine to generate outputs A and B, corresponding to TH and TL durations. Output A is for TH milliseconds, then output B is for TL milliseconds. The clock period is 1 millisecond, so each state transition corresponds directly to time. As instructed, if TH or TL exceeds 4 millisecond, I limited them to 4 ms only for this task. I presented the state diagram to show transitions and the state table for clarity. and the HDL code that defines only the output behavior, not the full system. Here is the full code for my system. And now moving on to the part 4, where I've discussed some drawbacks and limitations for part 1 and 2, the questions. First, the system is limited by the counter size, so it can only support a fixed maximum number of cars. Second, using discrete 555 times about the drawbacks, modifications, and impacts. And for some improvements, I have implemented debouncing and priority logic for sensors. These changes would improve scalability, accuracy, and control, but it would increase the system complexity and cost. And now moving on to the conclusion, that concludes my presentation. This assignment has helped me understand how counters, timers, FSMs, and control logic work together in a real-world digital system. Thank you for your time. This is Ryan signing off.